Today we're going to be building a knurled knob out of brass. So we will be working in metal, we'll be building guitar parts, and I think we're going to get a blast out of this project because we're not just going to do any old knurl. We're going to make a Dyke Harms knurl. What's that? Take a look. So the first time I ever saw these really heavy knurled knobs was on the Lucky Dog Guitars website. And if you know Lucky Dog Guitars, they make fine Telecasters that are played by celebrities all over Nashville. This is the actual image that I'm talking about. These really heavy knurled knobs that are basically pointy. They're almost like little pyramids sticking out, and I'd never seen anything like that. So after several years went by, I actually Googled this knob, and it turns out it's made by someone called Dyke Harms. And Dyke Harms specializes in very, very boutique hardware for guitars. Here is the knob that we're talking about here. It is basically almost like a star pattern, and it's a star pattern that's rotated for each layer. This is what I want to build. So let's get to it. Let's get to the design phase, and let's actually try to build, as best we can, one of these Dyke Harms Telecaster knobs. When I first designed this is how I designed it, with an 8-sided polygon. But this is incorrect because there are no flat sides on the Dyke Harms Telecaster knob. So each one of these sides is actually curved. So it curves and dips up to the points. So what I had to do was make arcs instead of lines for each one of these sides. And this is what it actually looks like. So instead of a flat surface between points, it's an arc between points. All we have to do now is take that and rotate it, and it'll look something like this. So once we have our two stars that are rotated properly, we can start extruding layers. And now this is where we start to have to make some guesses. How tall are each one of these layers? If we look at the reference photos, they're different. Notice how this bottom layer is much, much thinner than the middle layers. And then in the other reference photo, we clearly see that the top layer is much thinner. And the top layer has a loft that lets it gradually sweep into the actual flat top. So what I landed on was 3.9 millimeters for the middle layers, 2.7 millimeters for the bottom layer, and the top layer is 2.5 millimeters. And we clearly start building up till we get to our height. So I think it's 21 or 22 millimeters tall. So here's the top part, which lofts just like the actual reference image. So as you can see, each arc sweeps into the actual flat top and makes this beautiful, beautiful little kind of bevel. And the finished product would be like this, where we have the proper shaft diameter for a CTS pot.